Hello everyone, my name is Hari Krishna Araki Kandavir. My metric number is 01DEM5012209 and my partner name is Satishwaran Analaki Sundaram and his metric number is 01DEM20F2011. Our group title is Hardware Interfacing 3, Interfacing Microcontroller PIC 16F877A with 7 segment with this sequence. The sequence are 7 segment display start from 0 until F. After display F, it repeat again the sequence. First, we're going to see about the theory. A 7 segment display is a commonly used electronic display device that displays decimal digits 0 to 9 and some alphabets A to F using a combination of 7 LED segments. Each segment is assigned a letter A to G and is used to display a particular number or letter. Thus, common anode and common cathode of all the LEDs are connected to a single pin of the display. The PIC 16F877A is a microcontroller that can be used to interface with a 7-segment display. The microcontroller can control the 7-segment display by sending specific signals to the individual LED segments through its output pins. By controlling which LED segments are lit up, the microcontroller can display any number or letter on the 7-segment display. To display the sequence from 0 to F and then repeat, the microcontroller can use a loop that counts from 0 to F and display each number or letter in the sequence using the appropriate LED segments. Once the sequence reaches F, the loop can reset and start over from 0, thus repeats the sequence indefinitely. The process of interfacing a microcontroller with a 7-segment display involves setting up the microcontroller's output pins to the appropriate configuration and writing down the sense signals to those pins to control the individual LED segments of the display. The specific code used to achieve this will depend on the programming language used and the specific microcontroller being used.
I will be explaining about the coding used. First is void main. This is the main function used when the microcontroller is powered on. It has a void return type, which means it does not return a value. Next is unsigned character count equals to 0. This creates an unsigned character variable called count and initializes it to 0. This variable will be used to keep track of which digit is currently being displayed on the 7-segment display. Next is the unsigned character segments. This creates an array called segments that holds the hexadecimal values to display each digit on the 7-segment display. This array is initialized with values for digit 0 until F. Next is trace C. This sets all pins on port C to output mode so they can be used to control the 7-segment display. Below that is port C. This initializes all pins on port C to a low state 0, which turns off all segments on the 7-segment display. Next is the while one. This creates an infinite loop that will continuously run as long as the microcontroller is powered on. Port C equals segments in brackets count. This sets the value of port C to the value in the segments array at the index specified by count. For example, if count is 3, then segment in bracket count is 0x4 the hex code, which will display the digit 3 on the 7-segment display. Count plus plus. This increments the value of count by 1. Next will be if in brackets count as 0x_f count equals to 0. This checks if the values of count is greater than 0x0f, which is the hexadecimal value of 15. If count is greater than 0x0f, then it is set back to 0, so that the display sequence starts over from 0. Delay underscore ms in brackets 500. This pauses the program for 500 milliseconds, which creates a delay between each display. This is necessary so that digits can be seen on the 7-segment display when it's updated each time. Now we'll be looking how we run the program on a simulation in Proteus 8. We right click the PIC, we upload our hex file, we press run, and as you can see, it will go from number 0 until number 9, and will continue from A until F, and it loop around infinitely. So it will start again from 0 until F. It won't stop. It only stop if we off the stimulation.
Discussion. While displaying the sequence from 0 to F and the repeating, it may seem like a simple task. It is a fundamental concept that can be used in a variety of applications. For example, in digital clock or timer, the sequence from 0 to 9 is often displayed on one or more 7-segment display to indicate the current time or elapsed time. Similarly, in temperature monitoring system, the temperature can be displayed on a 7-segment display using a similar interface. To demonstrations, the versatility and usefulness of interfacing microcontrollers with 7-segment display to display numeric or alphanumeric data. Conclusion: interfacing a microcontroller like PIC 16F877A with a 7-segment display to display the sequence from 0 to F and repeat it is a relatively straightforward process that involving controlling the individual LED segments of the display using the microcontroller's output pin and writing down to implement the desired sequence. Thank you.